We're going to still be working with triangles in this next unit, but you're going to be having to simplify some radical expressions. So I wanted to recall some Algebra 1 skills, or maybe it's new. So making sure that you can simplify a radical, which means that if you have a square root above a symbol, which is a radical sign, that you take out all of the perfect squares. So the first thing I did is I just listed all of the perfect squares from 1 to 12. So a perfect square is just a number squared. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. So what we're going to do is you have to divide any perfect squares that will go in here evenly and take those out of that square root sign. So for example, if I was going to simplify the square root of 32, I would want to find a perfect square that goes into it. So typically you want to find the biggest one. So I found the 16 would divide evenly into 32. So I split it up so that I could do the square root of 16 and the square root of 2, because 16 times 2 is 32. Then what I do is I simplify. The square root of 16 is a nice whole number, which is 4. Then I check, can I split up the square root of 2? So are there any perfect squares that would divide evenly into 2? Well, yes, 1, but that's not going to change anything. So I would just write out my answer with all of them. So 4 as a whole number with no square root sign, and then the square root of 2. So this is what your answer would look like for simplifying the square root. Now, if you cannot find the biggest perfect square that goes into it, you can just find the first one. So you may have split it up as the square root of 4 times the square root of 8, which is fine. You can do it that way. The square root of 4 then would have changed to just a nice positive 2. The square root of 8, I would have had to check to see if there's any factors that would go in there. So there is. I can take this 4 and divide into 8. So if I split up the square root of 8, it would become the square root of 4 times the square root of 2. The square root of 4 would become 2 as a whole number, and then the square root of 2 would be done because there'd be no other perfect squares. So then I would have 2 whole numbers with no square root signs, and then times the square root of 2. So that means I would need to times these whole numbers to give you 4, and so you still get the same answer as 4 square roots of 2. So I just wanted to show you that there are 2 different ways. If you don't get the biggest perfect square that goes in there, just always check that one on the right and make sure that there aren't any other factors. Okay, let's go through one more together to make sure you kind of get the hang of it. So we have square root of 28. So I'm looking for the biggest perfect square that would go into 28. The biggest perfect square would be 4. So 28 divided by 4 would be 7. So I would split it up as the square root of 4 times the square root of 7. Square root of 4 would be a nice whole number of 2. Square root of 7, I would check if there's any other perfect squares that would go into it, and there is not. So my answer would be 2 square roots of 7. Alright, pause the video and see if you can simplify the square root of 24. So the square root of 24 could be split up as the square root of 4 times the square root of 6. Square root of 4 is a nice whole number of 2, and then square root of 6 would not simplify any further, so my answer would be 2 square roots of 6. Okay, so the first part of this is making sure that you can simplify those radicals. The second part is making sure you can rationalize a denominator. So what that means is you can never have a radical symbol in the denominator of your fraction. So sometimes it'll be nice and easy. Like if I had the square root of 13 over 100, I could split it up and do the square root of the top and the bottom, since the square root bracket is around the entire fraction. Then I could simplify. Well, square root of 13 would not simplify any further because there's no perfect squares that go into it. However, the square root of 100 is a nice whole number of 10. So as soon as I simplified the square roots, it got rid of my square root in the denominator, so this would technically be simplified because there's no square root in the denominator. Let's look at another one. Number 5. I don't have a big square root like I did around number 4. It's just around the denominator. So first thing I would look at, can I do the square root of 12? Nope, that's not a nice whole number. So then I would need to simplify like we did up top here. So I would need to find a perfect square that goes into 12. Well, I could break it up as the square root of 4 and the square root of 3. Square root of 4 is 2 as a nice whole number, and then square root of 3 cannot simplify. So right now, in the denominator of my fraction, I would currently have 4 over 2 square roots of 3. Remember I said that it's not simplified if you have a radical in the denominator. So first thing I would want to do is check to see if these whole numbers will reduce. So can I reduce 4 over 2 as a fraction? Yeah, it would reduce to 2 over 1. Then the next thing I would want to do is get rid of this radical in the denominator. So in order to do that, what you do is you times the top and the bottom by that same radical symbol. So what I would do is I would do multiply straight across. 2 times square root of 3 would be 2 square roots of 3. 1 square root of 3 times square root of 3, I could just ignore that 1 for the time being and times my radical, so it would be square root of 9 on the denominator. When you times by that same radical, you should end up with a nice perfect square, because if you're thinking about it, square root of 9 would simplify to a nice whole number, which is just 3. So you're doing a couple things here. One, you have to simplify like we did on the previous skill, and then two, you have to make sure there's no radicals in the denominator, so we call that rationalizing the denominator, where you times the top and bottom by that same radical. Alright, pause the video and see if you can do the last one. Okay, on the last one, I have 5 over square root of 75. So I would first break up the square root of 75. So that should be broke up as 5 square roots of 3. Then I rewrite my new fraction. So now I have 5 over 5 square roots of 3. Notice the 5 over 5 with the whole numbers will reduce as a fraction to 1 over 1. Then I see I have a radical still in the denominator, so I need to times the top and the bottom of my fraction by that same radical and times straight across. So 1 times square root of 3 is just 1 square root of 3. 1 square root of 3 times square root of 3 would be square root of 9. And then square root of 9 should simplify to a nice whole number of 3. So your final answer is square root of 3 over 3. Okay, if you still have questions on either simplifying radicals or rationalizing the denominator, let me know. Otherwise, you can go ahead and start on your worksheet.